Hello and welcome to my channel. In this video I'm going to show you how this Hall sensor module works and how you can use them for your projects. If you are interested in this sensor or in the kit where it's coming from, I will let you a link in the description below. So let's get started. Hall sensors are very popular those days. They can be used in many applications. For example, you can use them in a DC motor in order to sense the position. And with a little bit of mathematics, you can also calculate the speed and the acceleration of the motor. They are also used as magnetic switches or proximity sensors. So now let's have a look how this is working. A Hall sensor is actually nothing else than a thin conductive plate through which one flows a current. There are also a little bit of electronics behind this, but we are not going deep in detail in this video. So let's imagine we have a thin conductive plate and we let current flow through it. The current will then flow from the negative side to the positive side, as you can see on the animation. Now let's take a magnet and place it in front of the conductive plate. If we do this, the magnetic field of the magnet will interact with the conductive plate. The electrons that was flowing straight through this conductive plate will now be attracted or repelled depending on the polarity of the magnet. And this is called Hall effect. Let's say with the north pole of the magnet, the electrons are attracted, and with the south pole of the magnet, the electrons are repelled. So if we put the north pole of the magnet next to the conductive plate, the electrons will be attracted on one side, and on the other side we will have holes, which is nothing else than atoms that are missing an electron. Now, if we take a measurement instrument and measure the voltage between both sides of the conductive plate, we will read a voltage. And this voltage is also known as Hall voltage. If you sense this voltage with a microcontroller, you can easily know if a magnet is in the near of the Hall sensor or not. And with this you can realize all the applications we did talk about earlier. So now let's have a look on the module. This component here is a Hall sensor. Here we have a resistor and here a red LED. We can see 3 pins. The pin on the right is the signal output pin. The pin in the middle is the supply voltage pin and the pin on the left is the ground pin. So now let's connect this module to our Arduino. So for this we will need a breadboard, the Hall sensor module, and a few jumper wires. First of all, we will connect the ground to the Arduino ground. Then connect the supply to the 5 volt of the Arduino, and finally connect the output of the module to the pin number 4 of the Arduino. And now connect the Arduino to the PC. Now we are ready to program this module. So let's have a look on the code. First of all, I defined a variable Hall sensor pin, in which one I defined the communication pin between the module and the Arduino. Then I defined a variable Hall sensor value, in which one I will store the value or the state of the module. In the setup, I initialized and start the serial monitor with a baud rate of 9600. Then I defined the communication pin between the module and the Arduino as an input. That means that the module is sending data to the Arduino. In the loop, with the digital read function, I actually read the pin of the Arduino that communicates with our module and store the value in our variable Hall sensor value. Then I print this value on the serial monitor. So let's see if this works. For this, I will use a simple round magnet that you can find in any hardware store. So if I move the magnet near to the Hall sensor, the module will catch the magnetic field and light up the red LED. And this works for both sides of the Hall sensor. Now if I am changing the pole that are facing to the Hall sensor, the Hall sensor will not react because the Hall sensor is sensitive to the magnetic polarity. This is very important to know if you want to use this sensor in your projects. So now, let's see the state of this module in the serial monitor. If this Hall sensor module don't detect any magnetic field, his state or value will be 1 or 5 volts. If this module detects a magnetic field, his state will switch from 1 to 0. I hope this video was helpful for you. I'll be very happy if you let me a feedback in the description. Thanks for watching, leave a like, share, subscribe, and see you next time.